Guys, today's notes are on 9.2 and we're going to be learning about angles and radian measures. In this lesson, we're going to expand our study of angles to include angles with measures that can be any real numbers. And so we're going to talk about drawing angles in standard position. So first, what is an angle in standard position? Well, in a coordinate plane, an angle can be formed by fixing one ray, called the initial side, and rotating the other ray, called the terminal side. Terminal side about the vertex. So really what it is that if you have a ray that goes on forever, and then we rotate this ray however much I want, right? The blue one is your initial and the red one is your terminal. So in standard position, the vertex is at the origin. Okay, so here's my x and y. And so we start here. And let's say this is my red pen, right? So my initial side is here. And then it's on the positive x-axis. So this is how we always start. And then when we measure an angle that's positive, the rotation of the terminal side is counterclockwise. So this way is positive. But if we go the other way and go clockwise, then that is negative. And what we can do is we can actually rotate the angle more than 360. So what we're going to do then is go all the way around. That's 360, and then I could add like 40 more if I wanted to, for a total of 400. And so what we're going to do now is draw angles in standard position. Okay, so just nice and straightforward. So starting here, we're going to have our, maybe I should do it this way. Ready? We'll do our x and y axis. Starting position will be right here. And then here's the thing you need to know, that 65 is less than 90, right? So the y-axis is 90, and then I'm going to go past 45, which is in the middle, and then up to 65. Now I'm going to put my arrow there to show that I have gone up positive 65 degrees. Okay. Next, I'm going to do 300. And so 300, you have to think about like how many quadrants do you have, right? So this first one is, first draw your initial angle, or initial side. We're going to go up 90, 180, 270, plus 30 more. So if your halfway point is here for 45, then I need to be less. And then we would label this as 300 degrees. Do you see how I have an arrow here showing me which way I'm going and where I end? This is my 45 degree line, right? So it has to be less than the 45 degrees. Okay? How do I do 500? Well, if there's more than 360, it just means I'm going to do more than one circle, right? So I'm going to go, it's positive, so I'm going to go counterclockwise. I'm going to go all the way around to 360, and I know I have to go more, but how much more? So 500 minus 360 is 140, so I'm going to keep going to 90 more. It's less than 80 more, or like 180 more, right? So it'll be right around here. My 45 degrees is here. That's 135, so I'm going to go a little bit more than halfway. So this will be, please label with your angle measurement, 500 degrees, and I'll point an arrow going this way. Okay. The last one is negative, and so we've gone counterclockwise many angles now. Oh, I should also include my initial side. That's the one I sometimes forget. So that when you look at this, this angle has two measures, So you can go 500 all the way across, or if you count it just from beginning to end and you look at this part right here, that's 140 degrees, right? We'll talk about that next. Okay, so let's see. We have our initial side. We're going to go negative 100, so that's going to be negative 90 plus a little more, and that'll be negative 100 degrees. So what is this called when we have two angles that can be represented using 540? These are called coterminal. Because their terminal side coincides, right? So if it's coterminal, they're sharing a terminal. And an angle coterminal can be found with another angle, can be found by adding or subtracting multiples of 360. Right, so I could go around, I could stop here at 140, or I could do an extra loop, right, and add 360, or I could add another 360 and another one. So the number could be infinitely larger, and I could have multiple coterminal angles. Okay, so coterminal angles, what we're going to do is add or subtract 360, right, until we get one positive and one negative. Ideally, I would like you to find the smallest positive and the smallest negative angle, just because there's no reason for you to do extra work. Okay, so I'm going to highlight here multiplying, adding or subtracting by multiples of 360. So let's see, I have negative 45 plus 360, which is 315 degrees. So that's one positive, right? That's one of the ones we're looking for. And then I can go negative 45 minus 360 degrees, which is negative 405. And so these two angles will end in the same place. One will just go counterclockwise and one will go clockwise. Hopefully you guys know that counterclockwise is like up and to the left, right? And clockwise goes like following the clock, 1, 2, 3, 4, 5, all the way around. Okay. These are the same. I'm gonna have you guys fill those out. Add and subtract 360, and I think this is the only one you got to be really careful of. When you get here and you add 360 to this one, you don't need to add more, because that'll give you a much bigger number. Do you see how 395 minus 360 is going to give you 35 degrees? Right, so that's my positive, and I want the smallest possible one. I don't want huge numbers. And then the other coterminal one is 35 minus 360 again, to get a negative number, which is negative 325 degrees. Hopefully that makes sense. Okay, so ideally I don't want like exponentially large or super large. I don't want 395 plus 360 again. Or you could subtract twice. So let's move on. We're going to now talk about something called radian measures. So far we've been using degrees, right? And so we know that a circle has 360 degrees. We can also measure angles in radians. So let's define what a radian is. We're going to consider a circle with radius r, centered at the origin, shown here. 1 radian is a measure of an angle in standard position whose terminal side intercepts an arc length r. So far, like, everything is good, right? Because the circumference of a circle is 2 pi, that means there are 2 pi radians in a full circle. Okay. So what does that mean? That means instead of saying a full circle is 360 degrees, you can say that 360 degrees is equal to the same as 2 pi radians, which means that 180 degrees, which is halfway, is equal to pi radians. And so you now have this, I would focus on this one or this one, whichever one works for you. This is a conversion ratio, right? And so we can use this ratio to convert between degrees and radians. Okay, so let's see. Right now I have degrees, and I want to convert to radians. So if I multiply, what you're really doing is you're taking either, let's do 180 degrees over pi, or pi over 180. Okay, these are the ratios that we're going to be multiplying by. So if I take 120 degrees, I want to end up with radians, right? So I want radians on top, and I want to cancel out degrees. So that means I'm going to use 180 degrees on the bottom and pi on top. When we have this, I can cancel out my degrees and degrees, which means I have 120 pi over 180. Please reduce your fraction. So I'm going to do some quick reducing. Zeros cross out. 12 and 18 can both be divided by 6, so that's 2 pi over 3 radians. Let's keep going. So now we have pi. Anytime you're given pi, that's a radian. So if I have pi on top, I want to cancel out pi's to end up with degrees. And do you guys see how this one allows me, if I multiply by 180 degrees divided by pi, now I can cancel out pi's. And I have only degrees left. So now I have negative 180 over 12 degrees. Okay, 18 over 12 is divide by 6, divide by 6. I can ignore the 0, so this will be 30 degrees divided by 5, nope, 2, sorry. Right, so I can divide by 6 here. Because I didn't know 180 could be divided by 12, and then I can divide by 2 and divide by 2, which gives me a total of 15 degrees. Oh, I lost my negative. So see if you can convert these real quick using the correct ratio, right? And remember that you always want something to cancel out. So if you start with degrees, you want degrees to cancel, and that's in the bottom. If you start with pi, you want pi's to cancel, and that's going to be in the bottom. So see if you get the next few answers, all right answers here, and you check them, please. Okay, so you need to show your work. So it's 3 pi over 4. Negative 2 pi over 9, and then 225 degrees, and 405 degrees. Okay? So I want you guys to see if you get these answers. Please show your work. Unpause the video when you're ready to move on. Okay, the last part is just a few word problems. And in order to do the word problems, we need a new definition, and we're going to talk about something called a sector. And a sector is a region that's bounded by 2 radii. So notice here, I'm going from the center to the edge 2 times, and there's an arc. So this sector, or you can think of it as like a piece of a pie, is what I'm talking about. The central angle theta of a sector is right here, right? So that's your theta. There are simple formulas for the arc length and area of a sector where the central angle is measured in radians. Okay, so here's your arc length and your area. So those are the 2 formulas that we're going to use. When we get to the next page, I'm going to write those down real quick. So let me copy this down. S equals r times theta. S is your arc length. Okay, so notice here, r is your radius, and your theta is your angle measure. And then my second one is area equals 1/2 r squared times theta. So now let's move on and solve some word problems. So we have a softball field that forms a sector with the dimensions shown. Find the length of the outfield fence and the area of the field. So here's my outfield fence. And then the area is this piece, right? So we're going to use both formulas. So really what we're doing is we need to make sure 2 things before we begin. We need to use radians because that's part of the definition. This formula only works if you're using radians. So let's convert. This is a 90-degree angle, right? So 90 degrees 2 radians. So that means 90 degrees. We know that's 1/2 pi, I think, because we're going to multiply by 180. Oh no, 180 degrees has to go on the bottom to cancel out, right? And then there's pi on top. 90 divided by 180 is 1/2. So it equals a pi over 2. Okay, once we have this, we can now move forward. And so we have our length of the outfield fence. So the arc length, which is S, equals r times theta. So arc length is what we're solving for. We know the radius is 200. We know the measure is not 90 degrees, but radians. So it's times pi over 2. And so our arc length equals 200 pi. Let's reduce 200 over 2, right, is 100 pi. Well, that's not really helpful, right? Like, we don't know what 100 pi is. Well, we can actually use pi on the calculator to figure out how long that fence actually is. Because if you went to like Home Depot and said, can I have 100 pi of fence, please? They would look at you like you're crazy. So please type in 100. Here's pi right here. You guys see that? So you go second, shift up, and there's your approximately 314 feet of fence. Okay, and then it says to find the area of the field. So let's find the area using my formula right here. I'll do area in blue, 1/2 times r squared times theta. And it's the same thing, it's just a formula, right? So we have 1/2. R squared is pi over 2 squared. Oh, sorry. R squared is 200 squared. Apologies. And then theta is pi over 2. Okay, well 200 squared is 400. So really what we have is 400 pi over 2 times 2 is 4, which is also 100 pi. So in this case, it happens to be that my area and my arc length are the same, but the answer is not the same. This is going to be 314, but it's not feet anymore. Look what we did here. This was 200 feet times 200 feet, so it's 200 feet squared for your area. Okay, be careful with your units there. Okay, so this next problem is exactly the same. We just need to remember to convert to radians first, always. Okay, and we have to figure out what we're looking for. So a person on the Earth notices that a 747 jumbo jet is flying overhead and it subtends or puts in an angle of 45 degrees. Okay, if the length of the jet is 230 feet, find its altitude to the nearest 1,000 feet. Okay, so few words we have to define. What's altitude? That's my height. Okay. So we do need to find our height here. You guys okay? And so there's a few things we need to find first. We have to find r first before we can find this height. So the first thing we're going to do is find the arc length, or use the arc length to find this. Okay, so maybe we don't need to use arc length. Let's draw our picture. We know this is 230. We know this is our altitude, A, right? And we want to find R. Okay, so I think here we have to assume that the arc length, or the jet, is pretty close. They're very close in there. So we're going to assume that an arc length is 230, which equals to r times theta. And so now we can solve for r. Okay. Before we can move forward, we need to convert 0.45 degrees to radians. Okay, so I'm going to do that over here. That's 0.45. Sorry about that. And that gives us, let's do it. 0.45 divided by 180. Let's do math. Okay, so that's pi over 400. I'm going to keep it as a fraction because that's how I like to work. So 230 equals to r times pi over 400. And we're going to solve for r. So r equals times 400 over pi. Right? Those cancel out. 400 times 230. So r equals 92,000 divided by pi. Okay. I'm going to keep it as an exact value, even though like it's, you know, it's a pretty nasty number, 92,000 divided by pi. It's not a nice number, but that's how far our plane is, right? So now we want to find its altitude, and we are going to, I guess, use the Pythagorean theorem maybe? What do we think? We can find our, now we can just keep going with the Pythagorean theorem. Is this correct? Okay, so altitude is always like directly up. So we have our r is 92,000 divided by pi. We know a is what we're looking for, and that this value is half of 230, so it's 230 divided by 2. And now we can use Pythagorean theorem. A squared, so that'll be 115 squared plus a squared equals to 92,000 divided by pi squared. This is obviously going to be a decimal value, and it says to round to the nearest 1,000 feet, so I'm not too worried. So I know that a squared is going to be 92,000 divided by pi squared minus 115 squared. Okay, since I'm rounding, I can type this all in. Oh, 92. Let's do this. Ready? Hit that. I'm going to square it. Minus 115 squared. Okay. That is crazy altitude. Is this problem correct? This does not make sense to me. Guys, I'm sorry. I'm brain dead. That number looks huge, but it's a square root of that number. So I'm going to do that now. Sorry. I'm so sorry. I'm not sure what's going on with me today right now. Which is approximately, so now I can do a second square root, and that gives me 29,284. But I want to round to the nearest 1,000, so it's really just 29,000 feet. Now, why did I do all this work if I got 29,000 already, right? Like, the idea is that, like, technically this would have been enough because this degree or this difference in angle measure is so small that it really makes not much of a difference. Okay, so this last problem, please pause the video. I'm sorry. I'm not going to do a picture, an example of this. I want you to do 3 things. Ready? I want you to draw a picture. I want you to decide which formula we're using. Okay? And then most importantly, I want you to make sure that you convert the 255 to radians in order to use the formula to answer this question. Okay? So you want to find the distance that it travels to the nearest inch, and then how many feet rounded to the nearest foot. And I'll give you my answers. I think the distance that the tip of the bat travels is 214 inches. And how many feet is this? Should be approximately 18 feet. Okay, so see if you get those 2 answers and bring that back tomorrow.